All right, so here's your notes for reflections. A reflection is like a reflection in the mirror, but when we talk about it, we talk about reflections over the axes. And so if you remember this first little line here, the one that you walk on, the crosswalk, is the x-axis, and the one that is vertical that goes up and down is your y-axis. And so when we're talking about reflecting, we talk about reflecting over those. You have to jump over whatever line you're reflecting over. Let's see. So yes, if you fold the coordinate grid in half, if you fold the axis, the paper on the axis, the reflection will land in the same spot. So if we're reflecting, the first thing in your note says to reflect it over the x-axis, this point here, it's 2, 3, which means we start at the origin. We go over 2 and up 3, and we're going to reflect it over the x-axis. The only way to do that is to jump exactly the same distance in a straight line over the x-axis. So it's 3 jumps to the axis, and so we need to do 3 jumps on the other side to make it right, an accurate reflection. And so the coordinates of that point are +2, and then we had to go down 3. Okay. Now it says that we need to take this same point and we're going to reflect it over the y-axis. And so we're going to bounce to the y-axis, 1, 2, and our point will be exactly the same distance on the other side. So it'll be 1, 2. So we'll have the ordered pair of -2 and +3 for that reflection. Don't forget your parentheses. Okay. And then the last one, it says, well, those are the only 2. So that's great. So notice that when we go over the y-axis, the x is the one that changes to the opposite. So it was 2 and now it's -2, but the 3 stays the same. The line that we're going over, it will stay exactly the same. So in this one, the original point where we flipped it over the x-axis, the x coordinate stayed the same, and the y is now the opposite because we're the opposite direction. But the numbers, the digits are the same. We just have an opposite sign. So let's go ahead and write that in your notes down here at the bottom. So if you flip something over the x-axis, the x coordinate, our coordinates are the same, and the y, the y coordinates have different signs. So it just changed the y to a negative or the other way. Okay, and so if we're going over the y-axis, you can barely see on my notes, but I'm going to just put them right here. We'll start with the x because you always go x first. The x coordinate have different signs, and the y coordinates okay. And so if you're going to flip it over both axes, if we're going to, I actually want you to totally ignore that last little part of the notes, because as long as you can flip over the x or over the y, you're good to go. We don't need to flip over both axes at this time.